hour. We have one more lesson for week 3. We're going to learn about parent functions. My joke with this is kind of always, who's your daddy? Who's the daddy function of all of these little transformed functions we're going to study? But for today, all you really need to know is the general shapes. I am going to go through the characteristics, but as much as anything, that's to reinforce what we did this week. All right, so these are all the different kinds of linear functions. This is generally what we're going to concentrate on, is this form. You can think of this as the identity function where y equals x or a constant, but we're just going to do this one. And we're going to call this y equals mx plus b. The domain is all real numbers, and the range is all real numbers, which you could write negative infinity to infinity. The x-intercept, when it is in its most generic form, is 0, 0. There are no extrema. The whole thing is increasing because it goes up as we go left to right. As soon as we put a negative slope in there, it's considered a reflection and it will be all decreasing. So the form we are in, it is increasing everywhere. And the end behavior, the form it is in, the left end, where x is getting more and more negative, would be left. And what's happening is the function, I'm just going to call it y, is going down, so negative infinity. On the other end, as x gets more and more positive off to the right, the function is getting higher and higher, or going up. It has no discontinuities, and it would be odd in its current form, right? If it went through the origin like that, we could rotate it 180 degrees. All right, so that's just a linear function. You guys are good with that one. The absolute value function is the v, okay? And this slide has some pretty colorful pictures, and it talks about the transformations we're going to do next week. The shifts left, right, up, down, and flipped, okay? So the overall, this is just called the absolute value. Oh, we're supposed to write an equation there. My bad. The absolute value is written on the side. We have y equals absolute value of x. The domain is all real numbers. And the range, it doesn't ever go, you can only have positive numbers, but you can put 0 in, and 0 will come out. You can put anything in, but you will always get positives out, or 0 at the lowest. So it crosses the x and y at 0, 0 in its most generic shape. It has a min. It would be an absolute min. It is decreasing as we go left to right, and then increasing. So decreasing, and then on the right side, increasing. Remember, these are x intervals. So the x causes the y. As x gets closer to 0, it is decreasing. The y values are decreasing here. All right, end behavior on the left, which would be x is negative infinity. It is going up, which would mean y towards infinity. On the other end, I don't know why I wrote a squiggle there. On the other end, it is also going up even as x goes up or off to the right. It has no discontinuities, and it has y-axis symmetry, so it is an even function. All right, we're going to talk about these as two separate functions. This slide shows that they all have the same transformation pattern. Okay, but we're going to talk about this one as quadratic. It's this shape, and this one as a cubic. Let me slide this down. All right. when it's an odd degree. So we'll do quadratic first. And the parent function would just be, let's switch colors here, enough red. Y equals x squared. And then we're going to learn how to put transformations onto that. But the domain is all real numbers. The range, though, again, it only has positive. When you square something, it becomes positive. X-intercept and Y-intercept are still 0, 0. Extrema, it has an absolute min. And the Y value at the min is 0. And that happens at x equals 0. The increasing interval would be over here. It's going up from 0 to infinity. And the decreasing interval would be the left side, which means negative infinity till 0. Okay, and again, those are the x values, where it's the x's coming in from the left until 0 are what cause it to be decreasing. All right, end behavior, both ends are up, so y is positive on both sides, both as x is negative and as x is positive or going to the right. All right, it has no discontinuities, and what do you think, guys? Even exponent only, yx is symmetry, so it is even. All right, cubic. If I'm going too fast, just pause the video. Y equals x cubed. So this is the shape. It does still go through 0, 0, left end down, right end up. The whole thing is increasing this time. So domain is all real numbers, or we could write it like this. X-intercept and Y-intercept are still 0, 0. The extrema, it has none, okay? It has no maxes or mins. It has an inflection point, but that's it. It can, when we transform it, talk about extrema, but this one does not. It is entirely increasing, so from negative infinity to infinity, and it's never decreasing the way it's drawn. The end behavior, it is on the left, so as x goes left, it is going down. As x goes to the right, it is going up. It has no discontinuities, but if I rotate it 180, it'll look the same, so it's odd. All right. The radical functions, there's two of these we're going to talk about. The square root has only positive answers because we can only take the square root of positive numbers, and we only get out positive numbers. The cube root, though, you can take the cubed root of like -8, because -2 times -2 times -2 is -8. So cubed roots, you can put in negative numbers and you'll get out negative numbers. You put in positive numbers and you'll get out positive numbers. So those are the shapes for those. So this is a square root function. Because it's starting here and going this way, it is only x values that are positive. We can only put in positive numbers and we will only get out positive numbers. It does go through 0, 0. It has, I guess, an absolute min. We don't really talk about that, but yeah, it stops right there. It is all increasing from, though, 0 to infinity, and we don't need to include 0 because it's never increasing or decreasing at a particular point. So when we do increasing and decreasing, we can always use parentheses. The only end behavior we really care about is off to the right. It is increasing. We could say as it gets closer to 0, as x approaches 0, the y value also approaches 0. But but it doesn't ever go negative. Not going to worry about that one. All right, discontinuities, there are none, and it is neither even nor odd, because you can't flip it across any axis and have it look exactly the same, and you can't rotate it 180. The cube root, on the other hand, if we rotate this one 180, it will be the same, so this one is odd, has no discontinuities. It is the cube root of x. This time it goes left to right and up and down forever, so it's all real numbers for both of these. It does go through 0, 0. There are no maxes or mins. Let's see, if we go left to right, the whole thing is increasing. And the end behavior on the left is going down. Okay, as x goes towards the positive or right, the y is also going up or towards positive infinity. All right, sorry, I did those really weird order. I don't know what's going on with my brain. All right, then we have a rational function. I think the only one in your notes is this first one, okay? But when you have an odd power in the denominator, it will be this shape. When you have an even power in the denominator, it does what I like to call a volcano shape, okay? This is a volcano shape. So the parent reciprocal function is just y equals 1 over x, where this is basically x is power of 1 or odd. Speaking of odd, if I rotate that 180, it will look the same. It does have a discontinuity. It is discontinuous when x equals 0, okay? It is undefined. Does that make sense, guys? The domain is everything except 0. Because you can't divide by 0. What comes out then is also everything but 0. If we go bottom to top, there is a 0 here, so the y can't be 0 either. All right, the y-intercepts, none. X-intercepts, none. Extrema, none. Increasing, well, this as you go left to right goes down, and this as you go left to right goes down. So this is none, but decreasing is the left branch and the right branch, but it is undefined in between those. End behavior, as you go off to the left, which means x is getting closer to negative infinity, the y values are getting closer and closer to 0. And as you go off to the right, so as x approaches infinity, the y values are getting closer to 0 again. Remember, we had that in our notes where it can approach a particular value, not always infinity. All right. Then we have exponential graphs. Now, this one talks about exponential growth and decay. It depends what the base is, but this shape, okay, where there's, let me scooch it up a little bit, where there's an asymptote that it's approaching, a horizontal line it never crosses, okay, that is an exponential graph. So the parent function we're going to write down is y equals e to the x, or y equals any number b to the x. We're not going to do a whole lot of these. We have a whole chapter on these separate, so I'm not going to go too in-depth with this. The domain, you can put anything into the exponent, but as you can see, it will always be positive. It will not ever actually be 0. It doesn't ever cross the x-axis in this format, but no matter what, when you put in any number to the 0 is 1, So therefore it has a y-intercept of 0, 1. It has no extrema, and the whole thing in this case is increasing. If it was an exponential decay, where b was less than 1, so you had like 1/2 to the x, then the whole thing would be decreasing. Again, have a whole separate chapter on this stuff. So end behavior, just reviewing what we've been working on, left end is getting closer to 0, but the right end is going up forever. It is neither even nor odd, and it has no discontinuities. Logarithmic is the inverse function for an exponential function. So they have a really funny looking one here. The one on our page is a little flatter, but it can be y equals ln of x or y equals log base anything of x. And again, this is part of that exponential chapter. We'll get there eventually. Just to review, it's all to the right of the y-axis, so it has a domain of positive numbers. The range is actually all real numbers. It crosses the x at 1, 0, because it's the inverse, remember, of the one we did a minute ago. The y-intercept is none. It has no extrema. It is not even or odd. It has no discontinuities. It is all increasing. Again, that depends on the base and whether it's been reflected. It's actually not got any pieces at negative infinity, so it would be from 0 to the right. Did I do the last one right? Yeah, this had all real numbers. Okay, sorry. It's not decreasing. The end behavior, the right end goes up, and that's all we're going to worry about, okay? It goes up as x goes towards infinity. Again, whole other chapter on that stuff. Right. This is a weird one, guys. This is the greatest integer function, and I don't usually do a lot of these because they're tricky, but it's probably one of the most real-life functions we'll talk about, because this is those situations where you have to round down to the last integer. Okay, it's also called the round down function. Now, rounding up or rounding down happens all the time in the real world. Okay, and it talks about when you have data that has to be rounded to a whole number. Okay, so anything we talk about between 0 and 1 stays at 0. Anything from 1 to 2 stays at 1. Okay, but once you hit 2, then it jumps up to the next integer. So the domain, okay, it looks like this. It is a double looking thing like this, usually in people's notes. On our calculator, it is INT. And I'm going to show you where that is real quick. If you were at y equals and you go to math, and arrow to the right wants to numbers up here, it is this one, and I'll put this on the slides. Come on, what's happening? There we go. This one at the top here is the absolute value. Which is this one. Okay, but this guy down here, the INT, is y equals this guy. And I don't think when you type it on the calculator that it does anything exciting. Let's see, it's number 5. I don't think it puts a symbol. It just puts INT on there. But if you graph it, oh my goodness, what do I have? zoom 6, I get all those little steps. Okay, it's called the step function, the greatest integer function. Okay, you can call it the step function. Now, I'm going to have to pause the video because I think I need to move that all out of the way, and I'm afraid I have to move it down. All right, I had to move all that off the graph for you. All right, this one, you can put anything in, but you will only get out integers. So like -2, -1, 0, 1, 2, okay? I'm not going to worry about any of this characteristics here. It is not even or odd, and honestly, I don't care about any of the rest of this. It's honestly more important to me to spend maybe a second explaining how this works. If you were to put in the number 2, it would stay at 2. If you were to put in the number 2.1, it would stay at 2. If you were to put in the number 2.9, it would stay at 2. It does not move up to the next integer until you get past the next integer. So 3.7 would be 3. It always rounds down. Now we get a little tricky when we do negative numbers though, because -2.7 rounds down, which means left. So this rounds down to -3. So be real careful if they're negative, okay? So -1.1 actually rounds all the way down to -2. All right, I'd rather talk about that than all the goofiness of the graph. All right, the last two, I don't really even need to talk about at all. They're just fun to look at because we're eventually going to study these a lot in the second half of this course. But some of you are just now in trig, so I don't want to get you all confused about these. All right, sine and cosine functions are what are called periodic functions, which mean they repeat. Some of you have already studied this, some of you have not. Okay, this is y equals sine of x. It has a domain of all real numbers and a range from -1 to 1. It only fluctuates between those two y values. If you notice the x-axis is counted off with pi on it, that's because those are in radians. We'll learn more about that. But this one goes through 0, 0. All right, and it has extrema every pi over 2. It's either a max or a min. I'm not going to talk about any of that. It is an odd function, though, because it goes through 0, 0, and you could rotate it 180. All right, not going to worry about this right now. The cosine, on the other hand, domain is still all real numbers, and the range is still -1 to 1. But this time it does not go through 0, 0. It has a max on the y-axis. So the y-intercept is 0, 1. And it has x-intercepts that repeat. Oh, I should have talked about that on the last one. X-intercepts repeat. Let me go back here. It goes through 0, 0. And then it goes through pi 0. And it goes through 2 pi 0. And it keeps going. All right. And this one, it goes through pi over 2, 0, and then 3 pi over 2, 0, etc., etc. Again, none of this is important, but this is an even function. Spend a whole bunch of time on this in a month or so when we get to the second half of the course. All right, that's it. The rest are things we're going to talk about on Monday. Have a great weekend.